Hey y'all, in this video we're going to talk about the different types of reasoning that we need in order to do geometry. So we're going to start with inductive reasoning because you kind of have to start with inductive reasoning when you build your axiomatic system, right? You got to make some observations, you got to do some measurements, you got to collect your data, you got to go look back at your data, right? Look for some patterns. What do you notice what's going on? Then you can kind of make some generalizations based on the things you see. That process is inductive reasoning, and we need it in geometry because that's how we create our conjectures, right? We'll see something going on like, oh, I don't know, the opposite sides of a rectangle are congruent, right? And so if I change the size of the rectangle, make a bunch of different rectangles, do a bunch of different measurements, and I always see that, hey, the two sides that are opposite each other are always equal. And then I'm going to formulate a conjecture based on inductive reasoning from the data I collected and the pattern that I'm noticing. Okay, now many of you have already done this with these guys, the vertical angles. And so when I introduced this concept to you of the vertical angle, I showed you the vocabulary word. I asked you, like, hey, think about what's true. And I've mentioned this several times in class. What's true about vertical angles? Well, you might have gotten a protractor out and measured it and been like, oh, hey, wait, that angle's 40 degrees. And that angle on the other side, the vertical angle, oh, hey, that's also 40 degrees. And then, oh, that's a perpendicular. If those are perpendicular, I didn't mark it perpendicular, but let's measure. 90 degrees, oh, those are 90 degrees. And the vertical angle, oh, that's also 90 degrees. And then you might have noticed this angle here. It's like, oh, wait, that angle's like 150 degrees. Oh, that angle opposite, it's also 150 degrees. And so a lot of you have realized that, oh, hey, I think vertical angles are congruent. So when you make that observation and you make that conclusion, you are using inductive reasoning. Now, we can't just rely on inductive reasoning because we might actually be wrong. This is something that can happen. You can notice a pattern. Maybe you don't take it far enough, and it turns out that your pattern breaks right after, that the very next example or something, right? So it's not enough to just assume things are true because we noticed a pattern. We have to prove it's true, which is where the second type of reasoning comes in. So when you go through the process of systematically showing someone that you're right, like that these statements follow logically, and they follow logically from things that we agreed on, like the axioms and the definitions and other proven facts, we are using deductive reasoning. And of course, we need deductive reasoning to be able to prove or convince others that our conclusions are correct. So basically, a proof is a convincing argument. And you've actually done quite a few of them, or at least a version of them in Algebra 1 when we make you show your work, right? I think, at least I told my kids this, I need you to show the work to prove that you did the work, right? And so I can take this simple equation and ask you to solve it and justify it, and basically you're using deductive reasoning because I'm going to use some assumptions like the field axioms and the properties of equality to prove it, and I'm going to create a little logical argument, a process that systematically shows that I'm right. So for example, I can be like, oh hey, this is multiplied by 5, so I'm going to divide both sides by 5. And why can I do that? Because the division property of equality says I can divide both sides of an equation by a number, and the equation is still true. And so then I get x minus 4 equals 7. I am using deductive reasoning. I am taking established axioms, things that we agreed are true, and using them to prove my case, right? And so then, oh hey, same thing here, x minus 4. If I add 4 to both sides, I get x equals 11. And why can I do that? Because of the addition property of equality, right? Another axiom that we all agree works. And so I have just proven to you, using deductive reasoning, that x equals 11. So now let's go back to our vertical angles, and let's actually try to prove that the vertical angles are congruent. So first off, I'm going to number them because they don't have numbers, they're not identifiable, and I need to be able to distinguish between them. So I'm going to number the angles, right? And my conjecture is that if I have vertical angles, then the angles are congruent. And so for example, 1 and 3 are vertical angles. So let's focus on them, okay? Now I didn't put any measurements on here, right? Because I'm trying to prove this to people. So if I try to prove things to people, I have to do it in a very general sense. So let's, instead of measuring like with a protractor, let's say I have the measure of angle 1 as kind of like a variable, right, that I'm going to use to represent the measure of any angle that's 1/2 of a vertical angle pair, right? Okay, now, oh, I know something that, hey, angle 1 and angle 2 form a linear pair. And I also know that linear pair are supplementary. So I'm using the established facts of, oh, hey, linear pairs exist, and 1 and 2 by definition are linear pairs, and therefore that one measure of angle 1 plus a measure of angle 2 are supplementary because linear pairs are supplementary. So I can establish this fact based on that, right? So measure of angle 1 plus measure of angle 2 is 180 degrees. Oh, well, hey, wait a minute. Angles 2 and 3 are also a linear pair. So that means, by the same logic, the measure of angle 2 plus the measure of angle 3 is also 180 degrees, right? So these two, 1 and 2, add to 180, and then 2 and 3 add up to 180. Oh, hey, and they both share a 2. So let's treat this like an algebra equation, since that's where most of my deductive reasoning experience is. And oh, hey, these are both equal to 180. So I guess that means, by substitution, I can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3, right? By substitution. And then, oh, hey, look, both sides of the equation have a measure of angle 2. So why don't I just use my subtraction property of equality and subtract off those identical angles measures on both sides, and I'm left with, oh, the conclusion that the measure of angle 1 is equal to the measure of angle 3. Oh, hey, I've just algebraically proven, and using my geometry knowledge of linear pairs being supplementary, that those two vertical angles are congruent. And I can, of course, make a similar argument with angles 2 and 4. So now we're going to look at a couple of examples, and your job is to identify the type of reasoning you would use to answer these questions. Okay, so I have triangle dog, and I'm telling you by the drawing, oh, look, that's isosceles, right? And then dog has a perimeter of 756 centimeters. And so I ask, oh, hey, if OG is 240 centimeters, what's DG? And remember, without any symbols, OG and DG are the distances between those 2 points. So how do I do this? Well, I'm going to use the fact that we all agree that perimeters of triangles are when I add up the 3 distances or lengths of those line segments, right? And I'm going to use the fact that isosceles triangles have 2 identical sides. And I can set up a little equation that's like, oh, hey, this side plus 240 equals 756, and then go through the process of solving the equation. So I am using established facts, isosceles, the way perimeters work, equation solving properties. So that means in order to solve this equation or to solve this problem, I'm using deductive reasoning. Okay, so how about this one? If I know that 1 times 1 is 1. I know that 11 times 11 is 121. And I'm being told that 111 times 111 is 12,321. And then also I'm being told that 1,111 times itself is, what, 1,234,321. So the question is, hey, what's 11,111 times itself going to be? Well, I could get out a calculator, but oh, hey, I don't have one, and I really can't use one in geometry. Oh, no. So what am I going to do? Well, I'm going to look at the pattern of these answers. Oh, it's a 1 and a 1, 2, 1. Then a 1, 2, 3, 2, 1. And then a 1, 2, 3, 4, 3, 2, 1. So I'm going to use this pattern that I observe, and I'm going to think, well, if the pattern holds, then this should be my answer, right? And so it is. And so then, oh no, what kind of reasoning did I use? Well, okay, I made some observations based on this data that I had, and I noticed a pattern, and I just continued the pattern. So this answer I got from inductive reasoning.